Imagine an AI agent exploring a dangerous world. To survive, it must reason. The foundation of this reasoning is often propositional logic, a system of pure Boolean algebra, where facts are strictly either true or false. We give the agent rules like if A implies B and A is true, then B is true. It's mathematically rigorous, giving our agent the power of absolute deduction. But as the world grows, a hidden, dramatic flaw in this system is waiting to trap our AI. In propositional logic, every distinct fact requires a completely unique symbol. If we want to say there is a pit in square 11, we define a variable, p11. What about square 12? That's an entirely new variable, p12. Propositional logic has no concept of objects, space, or relationships. It only sees isolated letters. For a developer, this means hard-coding the physics of your environment over and over again for every single coordinate. Let's look at a classic AI grid scenario. We want to state a simple rule. A pit causes a breeze in all adjacent squares. In propositional logic, we cannot just say all adjacent squares. We must write a massive formula explicitly linking every single pit variable to its specific breeze variables. A simple 4x4 grid requires over 100 logical rules. A chessboard? Tens of thousands. The complexity explodes, suffocating the agent's memory. To break free from this explosion, our AI needs a profound cognitive leap. It needs to stop seeing the world as a disconnected list of Booleans and start seeing objects and relations. We need a language that can say there exists a pit, or square x is next to square y. This is where first-order logic steps in. It introduces variables that represent abstract things in the world and predicates that describe their properties. First-order logic gives our developer a superpower, quantifiers. We get the universal quantifier, for all, and the existential quantifier, there exists. Now, we can rewrite those tens of thousands of rules into one elegant, universal equation for all squares and squares y. If x has a pit and is adjacent to I, then I has a breeze. Suddenly, the agent generalizes. The logic applies whether the grid is 4x4 or practically infinite. First-order logic transforms our AI from a simple calculator of facts into a system capable of complex, relational thought. The trade-off is inference speed. Searching through continuous objects and relations is computationally heavy. But for agents navigating complex, dynamic environments, propositional logic is a dead end. First-order logic provides the boundless expressive power required for true artificial intelligence, allowing agents to finally reason about the universe at scale.